Hello, Tom from Every Step Physics, EveryStepCalculus.com from San Diego here. That's where I live. I'm going to do a physics problem here. You can see it on the screen regarding springs. Trying to be the most watched spring solutions to your problems in physics ever. And you can get my program at www.everystepphysics.com. Costs $30. You get 350 or more programs that you load into your titanium calculator, and you can pass all your physics problems and tests and homework. All right. I'm going to go to physics, get to my menu, press enter, and I'm going to go up. I could scroll down, but I'm going to go up because S for springs is closer to the bottom of the alphabet. So I'm going to search here and find springs. Press enter. And this one has an angle given, so then we're going to use angled springs, number 3. And I'm already at what's searched for. We got mass here, we got the angle, we got the spring distance that is compressed, and we got the distance that something flows down a ramp with, okay, which is 6 meters. Let me explain this a little bit. For the distance going down the ramp, we have it at L. I'll show you that in a second. And the compression is the X value in springs. It's called stretch or compressed actions. So I'm going to press enter here and enter the variables. And we have to press alpha first before you enter anything in these entry lines here. So I'm going to press alpha, and the mass is 2 kilograms. And we're going to put in the compression or stretch of the spring, and that's given as alpha 1.3. That's given as meters, number 4. You can scroll down or press the number before the menu item. And the angle is given as alpha 25, alpha 25. And we're going to give L as 6 meters, alpha 6 meters. I always show you what you've entered. You can check it if you want. If you made a mistake, go back. I say it's okay. Big deal in spring when you're on an angle or anything is blocks on ramps or anything in physics is that you want to get the vertical component to something that's horizontal. For instance, these figures here are the hypotenuse, and then you're going to get the height vertical y-axis, which is sine, of course. And so we take L times sine of theta and come up with 2.5 meters for the height of the L, which is the distance down the ramp that this mass is flowing before it hits the spring. And we always are talking about potential energy, and this potential energy with regard to the distance down the mass on the top of the ramp has potential energy because of gravity, and it's sitting there with potential energy, and as soon as it's released, it goes down. When it gets to the bottom where it stops, that turns into mechanical energy or kinetic energy. And that's always the system, and because of conservation of energy, these always are equal to each other. So we press enter, And now we get the height of the compression, which is the x value, 1.3 meters times the sine of theta, and that equals 0.5494. Now, you're going to add these two together to come up with a total height of 3 meters. And we find the potential energy of that, which is the total, really the total energy of the whole system. And that equals, potential energy is not only equal to mgh, but it's also equal to 1/2 the constant times the stretch squared, or compressed squared, and equals 60.53. So then that PE, we use that formula to find K. We want to find the spring constant, which we haven't found yet, and so we do the algebra of this stuff and come up with 71.6 Newton meters. We can see all these things again. For instance, we want to find when the block just touches the spring. Well, that would be the potential energy of the L, okay? The mass flowing down the ramp until it hits the spring. That's where you, and you know, as it flows, it loses energy of potential and starts to gain the kinetic energy, etc., etc. So you've lost potential energy totally when it hits the spring. And so that is going to equal to 49.75, which is the answer of this first one here. And then, of course, we answered the spring constant of 71.633 Newton meters. So go to my site, buy my program, and pass physics. Have a good one.